2025 A-Level Combined Mathematics Paper 1 Part B Question number 12 Part A. Part B of the same question will be discussed in the next video. Part A has to do with permutations and combinations. Part A says 5 books that are different from each other are to be distributed amongst 3 students A, B and C. Then asks us to find the number of different ways in which, first off, A receives exactly 2 books, B receives exactly 2 books and C receives exactly 1 book. It then asks us to find the number of different ways in which each student receives at least 1 book. Now this second case where each student receives exactly 1 book is more complicated, as it requires us to check multiple cases where maybe one student gets 1 book and the other 2 get 2 books, or it is also possible that one student gets 3 books while the other 2 get 1 book each. Now here in this question it's important to note that at the top, since they said that the 5 books are different from each other, we need to assume that the 5 books are unique. Now this is important and significant because in some other versions of this question in previous years, we might sometimes have items to distribute that are non-unique. For example, in a previous question, we had to distribute oranges and mangoes. In that question, the oranges were treated as non-unique, meaning that giving orange number 1, to so to speak, to a certain person is the same as giving a second orange number 2, to that same person. The oranges are non-unique. However, in this case, if we have books labeled book 1, book 2, book 3, book 4 and book 5, then giving book 1 to a certain person is different from giving book 2 to that same person. So due to this, our choosing logic becomes slightly different. So that's all for this question. Let's now discuss how we can solve question number 1, and then we'll discuss how we can solve each of the cases of question number 2. Part number 1 can easily be solved by considering the situation at hand and simply considering the different number of choices we have at each step when we're giving A exactly 2 books, B exactly 2 books and C exactly 1 book. Now you don't have to do it like this, you don't have to draw out all of these books and the students in your answer sheet, but if you want to, you can. So let's consider the situation where we have 5 books which I'm going to label as book 1, book 2, book 3, book 4 and book 5. Now let's consider giving these books away to A, B and C. If we want to first give A exactly 2 books, then we have a choice to make. We have a choice in which books we give to A. So let's say we give 2 books to A. It could be book 1 and book 2. It could be book 1 and book 3. It could be book 2 and book 3 and so on and so forth. It could be any number of books. Now, in order to find the different number of ways in which we can choose 2 books, as we know, we need to use the choose function. So in this case, we have 5 total books that we need to choose from, and we need to choose 2 of them to go to A. So if we're choosing 2 of them to go to A out of the total 5, then the total number of ways in which we can choose the 2 books that go to A is 5 choose 2. So now let's imagine that we've given these 2 books to A. So now if we've given the 2 books to A, then those 2 books are gone from this set of 5 total books. They are no longer available for us to give them to any of the other students. So now, considering the second person B needs to also receive exactly 2 books. But now, the pool of books is only 3. So out of these 3, if he's going to get 2 books, then we need to choose which 2 books go to him. So therefore, out of the 3, we need to choose 2, which means that the total number of combinations that we have for choosing those 2 books to give to B is going to be 3 choose 2. And finally, when we give those 2 books to B, then we're going to have only 1 book available in our pool, and that book is going to have to go to C. So if we give that book to C, we're going to give 1 book to C. We're choosing that 1 book out of a pool of 1 books. So therefore, the different number of ways to choose the book that goes to C is going to be 1 choose 1. So this is going to be our answer. We're going to have 5 choose 2 different ways to choose the 2 books to A, and after doing that, when we multiply that by the different number of ways that we have to choose book for B, it's going to be 3 choose 2. We're going to multiply that by the different number of ways that we can choose books for C after doing all of that, which is going to be 1 choose 1, and the product of all of these is going to be our answer. Now we cannot structure our answer like this, of course. This is just a diagram to help illustrate what's happening. We need to instead write this in either sentences or using some kind of logic. So in my case, I'm going to write it with sentences. I'm going to say the ways, different number of ways, number of ways to give books to A is equal to 5 choose 2, since we need to choose 2 of the 5 total books in our pool to give to A. So now once we've given those 5 choose 2 those two books by doing the 5 choose 2 and giving those 2 books to A, we now have 3 books left in the pool, meaning that if we consider then the different number of ways to give books to B. Now that we've given 2 of the books to A, we have 3 total books to choose from. We have to choose 2 of them, so that we have 3 choose 2 total ways to give the books to B. So now, once we give those 2 books to B, we are left with a single book in our pool, which means that the different number of ways to give books to C is going to be the total number of books remaining, which is 1, choose the number of books that we need to give, which is going to be 1. So then we have 1 choose 1 different ways to give the books to C once we've given all the books to A and B. So now, if we consider each of these and we consider their product, that product is going to be the total different number of ways in which we can give the books to A, B, and C. So therefore, total ways, we could either write total ways and just write the answer, or we could write total ways to give books to 2 books to A, 2 books to B, and then 1 book to C, or something like that. But I'm just going to say total ways is equal to 5 choose 2 times 3 choose 2 times 1 choose 1. Now, as we know, n choose k is equal to n factorial divided by k factorial times n minus k factorial. So using this, if we substitute all of this stuff into here, we can see that what we're going to get is going to be 5 choose 2, which is going to be 5 factorial divided by 2 factorial times 3 factorial. So 5 factorial divided by 3 factorial 2 factorial multiplied by 3 choose 2, which is going to be 3 factorial divided by 2 factorial 1 factorial multiplied by 1 choose 1, which is going to be 1 factorial divided by 1 factorial times 1 minus 1 factorial is going to be 0 factorial. So this is going to be our answer. Now if we simplify this, we can see this 3 factorial and this 3 factorial cancel. So we have 5 factorial on top and 2 factorial and 2 factorial on the bottom. This 1 factorial divided by 1 factorial is going to be 1, and 0 factorial is also 1. So we have just 1 divided by 1 times 1, which is going to be 1. So this whole thing is just 1. As for the rest of it, we have 5 factorial, which is 5 times 4 times 3 times 2 times 1 on top, and on the bottom we have 2 factorial times 2 factorial, which is going to be 2 times 1 times 2 times 1. So this is going to cancel to this. We can also cancel this 2 for this as well, leaving us with just 5 times 3 times 2 as our answer, which if we simplify is going to be 5 times 2 is going to be 10 times 3 is going to be 30. So we have 30 total ways in order to give each of these books such that A receives 2 total books, B receives 2 total books, and C receives exactly 1 book. So A receives 2 books, B receives 2 books, and A receives 1 book. So this is going to be the answer for the first part of the question. Now, for the second part of the question, as I discussed, we're going to have multiple cases. In order to handle those cases, I've constructed a little table here. Now, in the mark scheme, generally, you will see a table like this. They generally do 2 things like this, so you don't need to write down each individual case word by word. You could write a table like this, and it's preferred to write a table like this, because if you write a table like this, then all of your cases and your overall structure of your answer will be much more easy to read. So if we consider this table, I've written down that books are given to A, B, and C. I've written down different columns where we can label the different numbers of books that are given to A, different number of books that are given to B, and the different number of books that are given to C. And to the right here, we can work out the total number of combinations for that particular situation. So first off, as I discussed, we could have 2 of the people getting 2 books each and the last person getting 1 book. Now, as for the different number of situations that we can have, we could have that A gets 2 books, B gets 2 books, and C gets 1 book. This situation is exactly what we solved in the first question. Now, additionally to this, we could also have that A gets 2 books, B gets 1 book, and C gets 2 books. And finally, we could have that A gets 1 book, B gets 2 books, and C gets 2 books. Now, these 3 cases here are the 3 cases where 2 of the people get 2 books each and 1 person gets only 1 book. Now, as the other case possible, we could have 1 of the people getting 3 books in total and the other 2 people getting only 1 book, since we have 5 total books to distribute. So therefore, we could have 3, 1, 1, but we could also have A getting 1, B getting 3, and C getting 1, and we could also have A getting 1, B getting 1, and C getting 3. Now, there are no other cases. Now, you might be wondering, some of you might be wondering, what about giving A 1 book, B 1 book, and C 1 book? Now, while this does give each person at least 1 book, we're missing 2 books. 2 books are still left to be given. Recalling the original question that it says we have to distribute these 5 books among these 3 people. Now generally in mathematics, when you're doing this kind of question, distribute means that we need to be left with 0 books once we are done giving all of them away. So for that reason, these are the only cases that we can have. We can either have 2 people getting 2 books each and 1 person getting 1 book, or 1 person getting 3 books and the other people getting 1 book each. We cannot have 1 person getting 4 books, because that would imply that 1 person must get 0 books, which we cannot do, since one person must, actually every person must get at least 1 book. So these are the cases involved. The case 111 is invalid. Also the cases where you have 1 book and 2 books is also invalid, since that will leave 1 book left over. So we have only these cases to deal with. And if we consider giving the books in each of these cases, for the first case we know it's going to be 5, choose 2, times 3, choose 2, times 1, choose 1. For the next one, however, from the 5 books we need to give 2 of them to A, so we have 5, choose 2. But then from the 3 books we only give 1 to B, so we have 3, choose 1. And then from the 2 remaining books we choose both of them and give them both to C. Now for the last one, we have 5 books, we choose 1 and give to A, so we have 5, choose 1, times we have 4 total books, we give 2 of them to B, so 4, choose 2, and then we have 2 total books left over, we give both of them to C, so 2, choose 2. Now for the last case, for the first one, we have 5 total books, we give 3 of them to A, so we have 5, choose 3, multiplied by, we have 2 total books, we give one of them to B, so we have 2, choose 1, and finally for the last book we give that book that we choose from the set of 1 books to C. For the next one, we have 5 books, we choose 1, and then from the remaining 4 books we choose 3, and from the remaining 1 book we choose 1. And finally we choose 1 from the 5 books, then we choose 1 from the 4 books, and then we choose 3 from the 3 books. So these are our combinations for each of these given situations. Now let's write them down and find our answer. So for the first one, we know exactly what this is equal to 30, since above we proved that it's equal to 30 from this thing right here. So we don't need to calculate it again, we can just write it directly. Now for the other 2 cases we do need to calculate. However, if you realize that these 3 have a symmetry with each other, you will realize that both of these are also equal to 30. But if we don't know that, if we don't see that, then if you calculate, 5 choose 2 is going to be equal to 10, times 3 choose 1 is going to be equal to 3, so this is going to be 10 times 3, which is 30, times 2 choose 2, 2 choose 2 is going to be 2 factorial, divided by 2 factorial times 0 factorial, which is going to be equal to 1. So therefore we have 10 times 3 times 1, which is going to be 30. For the next one, 5 choose 1 is going to be 5, 4 choose 2 is going to be 4 factorial, divided by 2 factorial times 2 factorial, which is going to be 4 factorial divided by 2 times 2, or 4, which is going to be 3 factorial, which is going to be 6. So we have 5 times 6, and 2 choose 2 is 1, so we have 5 times 6, which is 30. So this is also 30. Now for the other 3, for the first one we will calculate 5 choose 3 is equal to 5 factorial divided by 3 factorial times 2 factorial, which is going to be equal to 5 times 4 divided by actually 5 times 4 divided by 2, since this 3 is going to cancel with 3 times 2 times 1, leaving us with just 10. So that's going to be 10. So 5 choose 3 is 10, and then we have 2 choose 1, which is 2. So we have 10 times 2 times this, which is going to be 1. So we have 5 times 2, which is going to give us 10 times 2, which is going to give us 20. For the next one, we know that these 2 are also going to be equal to 20, since there's a symmetry with these. However, if we don't know that, we can calculate them as well. This is going to be 5 choose 1, which is 5. This is going to be 4 choose 3, which is the same as 4 choose 1, which is going to be 1. 4 choose 1, which is going to be 4. So we have 5 times 4, which is 20, times 1, which is going to be 20. For the next one, 5 choose 1 is going to be 5. 4 choose 1 is going to be 4. So therefore we have 20 times 1, which is going to be 20. So therefore the answer is going to be 30, 30, 30 here, and 20, 20, 20 here. So now, if we add all of these together, we can see we have 30 plus 30 plus 30, which is 90, plus 20 plus 20 plus 20, which is going to be 60, 60 plus 90 is going to be 150. Meaning that the total number of different ways that we can give all of these books such that each person gets at least 1 book is going to be 150. We're going to have the case where 2 people get 2 books each. We also have the case where 1 person gets 3 books and the other 2 only get 1. So I hope it's clear why 111 and 121 and all of those are not answers in this question. It's because we need all of the books to be distributed. So now if we write the final answer down here in a sentence, we can say that the total ways to distribute the books, and we should also probably say that such that each person gets at least one book. So we'll say such that each person gets at least one book is equal to 150, and that's going to be our final answer for this question. Now finally, if we discuss the marks awarded for this type of question at the start for question number 1, when we find the different number of ways to give books to A, different number of ways to give books to B, and different number of ways to give books to C, you're going to get 5 marks here, 5 marks here, and 5 marks here. Then, when you say that the total number of ways that you're going to have to distribute each of these books is going to be the product of these 3, which is 5 choose 2 times 3 choose 2 times 1 choose 1, we're going to get another 5 marks. Then, when you successfully simplify all of these down to get your final answer correctly of 30, you're going to get another 5 marks. Now, for the next part, you're generally expected to make a table like this. And in a table like this, you're going to have each of these rows getting a certain number of marks. Now, the first row where you have 2 to A, 2 to B, and 1 to C actually gets 0 marks. And the reason for that is that this exact question was solved previously up here. Due to that, you don't get any marks for this 30. However, for this one you get 5 marks, 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 and for this one you get 5 marks. And also additionally, you get 10 marks for marking all of these cases correctly, as in the 221, 212, 122, and 311, 131, and 113 cases correctly, you get another 10 marks. And finally, if you get the correct total and you write down the correct total in a sentence like this, and you say the total number of ways to distribute the books such that each person gets at least one book is 150, then you get another 10 marks for that. So this is the distribution of marks. That's going to be all for this video. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.